Economics, example 8, marginal cost. Suppose C of X is the total cost that a company incurs in producing X units of a certain commodity. The function C is called a cost function. If the number of items produced is increased from X1 to X2, then the additional cost is the change of C, which is equal to the C of X2 minus C of X1, and the average rate of change of the cost is the following. The change in C over the change in X, which is equal to C of X2 minus C of X1 over X2 minus X1, which could also be written as the C of X1 plus the change in X minus C of X1 over the change in X. Now, the limit of this quantity as the change in X approaches 0, and that is the instantaneous rate of change of cost with respect to the number of items produced, is called the marginal cost by economists. The marginal cost is equal to the limit as the change in X approaches 0 of the change in C over the change in X, which then is equal to the derivative of C with respect to X. Now, since X often takes on only integer values, it may not make literal sense to let the change of X approach 0, but we can always replace C of X by a smooth approximating function, as we saw in example 6. Now, taking the change of X is equal to 1 and n large so that the change of X is small compared to n, we have the following. C prime of n is approximately C of n plus 1 minus C of n. Thus, the marginal cost of producing units is approximately equal to the cost of producing one more unit. The n plus 1 first unit, it is often appropriate to represent a total cost function by a polynomial. In this polynomial, we can say C of X is equal to A plus BX plus CX squared plus DX cubed, where A represents the overhead cost, which is the rent, heat, maintenance, and other terms represent the cost of raw materials, labor, and so on. The cost of raw materials may be proportioned to X, but labor costs might depend partly on higher powers of X because of overtime costs and inefficiencies involved in larger scale operations. So for instance, suppose a company has estimated that the cost in dollars of producing X items is the following function. So we have C of X, and we're going to set that equal to 10,000 plus 5x plus 0.01x squared. Okay, so we want to find the marginal cost. Well, the marginal cost function is taking the derivative of this function. So if we take a derivative of that function, we're going to get C prime of x, which is going to equal 5 plus 0.02x. So therefore, there is our derivative. And now we want to find, okay, what is the marginal cost of production level of 500 items? And that's when x is equal to 500. So we want to find C prime of 500, and let's plug it into our derivative function. So it's going to be 5 plus 0.02 times 500. And so we end up getting $15, and that's $15 per item. Okay, so this gives us the rate at which the costs are increasing with respect to the production level of when x is equal to 500, and predicts the cost of the 501st item. The 501st item is the following. We want to find C of 501, and we want to subtract C of 500. So that equals the following. We're going to have 10,000 plus 5 times 501 and that's plus 0.01 times 501 squared, and then minus 10,000 plus 5 times 500 plus 0.01 times 500 squared. So when we do that, we then get the following. We get $15.01. So I want you to make notice that if you take a look at the derivative and this function, we can see that c prime of 500 is approximately equal to c of 501 minus c of 500. So, economists also study marginal demand, marginal revenue, and marginal profit, which are the derivatives of the demand, revenue, and profit functions. These will be considered in Chapter 4 after we have developed techniques for finding the maximum and minimum values of functions.